So now I want to show you how to simplify complex rational expressions, which is just a totally unfortunate name. They're not really all that complex, but what we mean, so remember, rational expression means a fraction, and then when we have complex, that means we have fractions within fractions. So our first example here, right, this is kind of like, I call it the big line, right, the big divider line. And then here's my big numerator, and I have two fractions up there, and then I have my big denominator, and I have two fractions down there. We know we're done, right? So the instructions are simplify, right? That awful word, because it's hard to know when to stop. So simplify, and what that means for complex fractions is you only have one division line. So one fraction when you're done. Okay. So right now I have 4 small ones and 1 big one. We want to get down to have just one fraction. So there are 2 different methods that you can use. I'm actually just going to show you one because it tends to be the one that most students go with. If you just can't get this one method that I'm going to show you to work out, go ahead and send me an email and I can show you the other way. Okay, so here we go. The way that we're going to do is we're going to start by finding a common denominator. For the fractions in the top. Okay, so we're going to add the 2 fractions that are in the numerator. So what's that common denominator? So I'm going to ignore the bottom. We're just looking at the top. How do I add those 2 fractions together? Right? So they need a common denominator. What's it going to be? Right? So it's going to be 2 times x is going to be your common denominator up here. So first fraction, it has the x, it needs the 2. So we're going to multiply top and bottom by 2. Second fraction, right, it has the 2, it needs the x. So we're going to multiply top and bottom by x. So I'm just looking at the top now. So I'm going to have 2 over 2x plus 1 over 2x, and then I can combine those, correct? I'm sorry, 1x, thank you. I can combine those, and now I have 2 plus x for the top over 2x. Okay, so I added the 2 fractions on the top by first getting a common denominator. So that's your first step. Second step, we're going to do the same thing for the bottom. So I'll write it a little more simply this time. We're just going to add, combine, in this case subtract, add the fractions on the bottom. Okay. So again, we're going to need a common denominator. So for this one, when I'm just looking at 3/4 minus 1 over x, the common denominator is going to be 4x. So we need to, right, build up the 2 fractions so they have the common denominator. So x over x for the 3/4 and 4 over 4 for the 1 over x. So we have 3x over 4x minus 4 over 4x. So altogether that is 3x minus 4 over 4x. Okay, so there's the big top and here's the big bottom. Here comes our big division line. Okay, so 1 over x plus 1/2 is equivalent to 2 plus x over 2x. 3/4 minus 1 over x is equivalent to 3x minus 4 over 4x. Now we have 2 more steps. So we have this fraction, right, the top fraction, divided by the bottom fraction. So when we divide by a fraction, the bottom, or second fraction, flips and multiplies. So we're going to flip the bottom fraction and multiply. So I have 2 plus x over 2x times, so the reciprocal, 4x over 3x minus 4. And then we're just going to say reduce slash simplify. Okay, so do you see any common factors there that I can get rid of before I write my final answer? There's not a ton, is there? Right, the 2 plus x, I don't have any 2 plus x factor, right? So in order for me to reduce this 2 plus x, I'd have to have a 2 plus x in parentheses down here on the denominator somewhere, and I don't. 2 times x, not the same. It's not common, right, with the 2 plus x. However, the 2x and the 4x, those are factors, right? Because it's 2x times 3x minus 4, and it's 4x times 2 plus x. So these guys are factors, so I can go ahead and reduce because I can cancel the x from both of them. And the 2 goes into 2 once and into the 4 twice. Okay, I'm ready to write my final answer. I'm going to go ahead and use my red pen here just because I got a lot of green going on. So final answer, it's 2 times, so we're just going to multiply across. So 2 times the 2 plus x. Since the 2 plus x, right, has more than one term, I'm going to wrap it in parentheses. On the bottom, right, I canceled all of that 2x, so that's just a 1, which I won't write, and then I have the 3x minus 4. You can put parentheses around the 3x minus 4 if you would like, but you don't have to since it's all by itself. Okay, so the next one should be a little bit faster, so we won't write our instructions again, right? We're just going to follow them. So the first thing, find a common denominator for the fractions in the top. I'm sorry, here, can you see the example? So it's 4 divided by 1 over x plus 7. So my numerator, my big numerator, right, is just the number 4. There's nothing really to do there. It's just going to be a 4. Let's do the bottom. And then we're going to add the fractions on the bottom. Now I do have something to do. I have 1 over x plus 7. I need to get that to be one fraction on the bottom. So what's the common denominator going to be? Well, right, so a lot of students like to stick a 1 under things that aren't already fractions. So I have 1 over x plus 7 over 1. So your common denominator would be x. So 1 over x, that's good. So we're going to multiply the other fraction, right, top and bottom by x. So what are we going to get on the bottom then? I've got 1 over x plus 7x over x. Oop, get my x in there. So that means I have 1 plus 7x all over x. And then here's my 4 from the top. Okay, so now I've combined. I have one thing on the top. I have one fraction on the bottom. So now we're at step 3. We're going to take that bottom fraction, bring it up, flip, and multiply. So I have 4 times the reciprocal of the bottom fraction. So 4 times x over 1 plus 7x. So look for anything that's common. I just stuck a 1 under my 4. Look for any factors that are common to reduce. Right? Be careful, right? The x from the top, right? I can't cancel it with this x that's multiplying my 7 because the x isn't multiplying everything else that's on the bottom. It's just multiplying by the 7, and then I've got this old plus 1 going on. So the x is not a factor of the denominator. So there's really nothing to do but multiply across. And now I'm writing down my final answer. Are you ready? So it's 4 times x, so 4x. 1 times, I don't write the 1 times, 1 plus 7x. Okay, last example. This one, I think I'm going to need a little bit more space. So I'm going to kind of go up and around with my work here. So we're going to add the 2 fractions in the top. Maybe I'll do that workspace up here. Okay, ready? So I have 3 plus 27 over x. I need to add my 2 top fractions. So put a 1 under the 3. Common denominator with these 2 fractions, but that would be x. So x for the top and bottom of the first fraction. So that's going to be 3x plus 27 over x. So that's my new version of the numerator. Big division line. And now we're going to do the same thing for the denominator. So now I have 1 minus 81 over x squared. I need to add those 2 fractions together. 1 over 1 if you'd like. So top and bottom by x squared. So x squared minus 81 over x squared. Okay, so that's my new denominator. X squared minus 81 over x squared. Okay, so one fraction on top, one fraction on bottom. Flip and multiply. So 3x plus 27 over x times reciprocal of the bottom, x squared divided by x squared minus 81. Now we need to look for common factors. So I chose this one so that we had some factoring to do because we don't want to get rusty on our factoring. So the 3x plus 27, that has a common factor. It's linear, x to the first, but I see that 3 goes into both of those terms. So I'm going to go ahead and factor the 3 out. So 3 times x plus 9. Okay. I've got my x down here, x squared minus 81, so I have a difference of squares. So those are, x plus 9 times x minus 9. Oh, sorry, scroll. So now let's see, do I have a third color? I'll grab the black pen. So now let's see what common factors we see. So I know you guys see the x plus 9s. It's nice when they're in parentheses. They just kind of stand out. So those guys are gone. I've got the 3 on the top, but I don't have a factor of 3 on the bottom. Even though you have that x minus 9, I can't cancel it because, again, the 9's not a factor on the bottom. It's just a term, so can't cancel that. But between the x and the x squared, those are factors because it's x times everything else on the bottom, x squared times everything else on the top. So I can get rid of this x here and one of those x's up there. So now let's gather up what's left. So I've got a 3 left here. I have an x to the first, so a 3x on the top. This thing here all canceled away, left behind a 1 that I don't need to write. And over here, the x minus 9 is left. Now, I said before, some students have trouble knowing when to stop. And why is it here that I have to stop? So this 3, the 3 is a factor on the top, but this 9 is not a factor on the bottom. So I don't have any factors on the denominator to cancel. The only way this could reduce is if I would have had a set of parentheses on the top with an x minus 9 in them. I don't, so I'm done.